Hello there and welcome to A2 Maths on Specimen Paper 1, and here we're looking at question 5, a algebraic division factor remainder theorem question. So f of x is equal to x cubed plus ax squared minus ax plus 48. Given that f minus 6 is 0, show that a is 4. Well, that's a pretty easy start to this question. All we need to do then is plug in minus 6 for the x coordinate, so it's going to be minus 6 cubed plus a lots of minus 6 squared plus, take away a lots of minus 6 and then plus 48 and set that equal to 0. So minus 6 cubed, so 6 cubed is going to be 216, so it's going to be minus 216 plus 36a plus 6a for the double negatives that appear there and there, plus 48 equals 0. So let's now combine this together. We're going to get 42a equals, and then it's going to be 216 minus 48 onto the other side. So that's 168. 168 divided by 42, let's just make sure we got that all correct, is the value 4. So lovely, good. Doing that on the calculator, we did get a as 4. Part 2 now, express f of x as the product of two algebraic factors. Well, if we know that minus 6 is a solution to this equation here, then x plus 6 is a factor. So let's write it out. X cubed plus 4x squared minus 4x plus 48 is going to have a factor of x plus 6, and now we need to think about what this second algebraic factor is going to be. Well, let's just think about it. If I expand the brackets, I need to get this expression on the left. So the first thing that needs to be in my right hand bracket is x squared, and when I expand the brackets I'm going to get x squared, so x cubed, plus 6x squared. However, I don't want 6x squared, I want 4x squared when I expand in total. So I need to take away 2x squared. So how do I do that? I need to take away 2x because that will multiply by the x to get me my minus 2x squared. The next thing that I'll get when I expand my bracket is a minus 12x. Now I don't want minus 12x, I want minus 4x. So I'm going to need to add back on 8 more x's. So the only way that that's going to happen is if I put an 8 here, so that 8 times x gives me my 8x. And then 8 times 6 is 48, so perfect. That is perfectly divided into x plus 6, x squared minus 2x plus 8. You could have done that by the long division method. Box method would have been fine as well. However, this is probably the more space saver, more efficient and more kind of intuitive way of doing it in my opinion. Moving on then, we are now given that 2 log 2x plus 2 plus log 2x minus log 2x minus 6 is equal to 3. Show that that expression is equal to 0. Okay, well, let's start off with 2 log 2 of x plus 2 plus log 2 of x minus log 2 of x minus 6 equaling 3. Okay, so first thing we need to do before we can add and subtract these logs is that this 2 needs to go inside the bracket. So it's going to be x plus 2 squared plus log 2 of x minus log 2 of x minus 6 equaling 3. Now we can add and subtract all these logs together. Now remember, when you add logs together, they multiply inside the log. So it's going to be x plus 2 squared times x, and then when it's a minus, it divides inside the log. So it's going to be x minus 6 on the bottom of a fraction there. That's going to equal 3. Now how do we get rid of the log? Well, we're going to do 2 to the power of both sides, because logs and powers are the opposites of each other, so it's now going to be x bracket x plus 2 squared over x minus 6 equals 2 to the power of 3, that's 8. So now let's expand all these brackets. X cubed plus 4x squared plus 4x equals 8x minus 48. So now let's take away 8x from both sides and add 48 onto the other side, and we get x cubed plus 4x squared minus 4x plus 48 equals 0. Lovely. So there we are. We've proven that part B is true. Part C, hence explain why this expression here has no real roots. Well, we know that this expression here is equivalent to this expression here. So x cubed plus 4x squared minus 4x plus 48 equals 0 is equivalent to part C. So now we can factorise it. We know how this factorises. It's x plus 6, and then to go back onto the other page, x squared minus 2x plus 8 equals 0. So either we have x equals minus 6, or, well, this bracket here doesn't have any roots because b squared minus 4ac is less than 0, so no real roots appear here. So now the only solution that we could possibly have is x equals minus 6. But if we look at part of this expression here, we're going to have log base 2 of minus 6, but you cannot log a negative. Remember, that's one of the rules of logs, that you can't ever log a negative number. You can't log 0 either. You cannot log a negative, therefore there are no real roots. Okay, so there we are, classic question where you have to combine what you've done in the previous two parts together to get your answer in part C. So there we are, quite a difficult question, that one. You do have to know a lot about logs, and you have to be very good at manipulating them into this expression that we did here in part B. So great question there, I think. Well done, edXL. So question 5, that's 10 marks. Let's now move on to question 6.